for sure. Let me share my screen. All right. Everyone can see that, I hope. Outstanding. All right. We aren't covering that much stuff this week, but the stuff that we're covering is incredibly complex. So please, 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 as always, interrupt me if you have any questions, and we'll try to take a look at some examples and things. All right, cool. So we really spent the last couple of weeks learning about JavaScript. We've been writing what's known as like vanilla JavaScript, or JavaScript that like works back to like 1998, right? 1998 to present. But there's a bunch of new stuff in JavaScript that really has taken JavaScript in a whole new direction and has made the language much more pleasant to work with. And I wanted to spend a couple of days really just diving in and understanding what are the changes and what are the things that are different. So the first thing that's probably really important to point out is that often you'll hear ES6 and JavaScript used interchangeably. ES6 stands for ECMA script version 6. ECMA script is the formal name of JavaScript, the programming language. JavaScript was created way back in the 90s, and they called it JavaScript so that it could leech off some of the marketing success of Java. But the two programming languages are completely different, and so it's caused a ton of confusion. You'll often be like, I need a Java programmer, but really they're talking about JavaScript. And so when they formalized the language, they decided that the real name of the language was not going to be JavaScript, but it was going to be ECMA script. And I don't know if that means anything. Let's see, ECMA. European Computer Manufacturers Association, which is the standards organization that controls the language itself. Okay? So ES6 and JavaScript are interchangeable, but ES6 is the recent version of JavaScript. It's the 6th version and has a lot of the functionality that we have not really covered to date. So some things to note with ES6 when we start learning this is that if you're working in an environment that has to support older browsers, some of this code will not work, and you'll have to maybe write more traditional or vanilla JavaScript. But the first thing we wanted to take a look at is variable declarations. So up till now, we've been declaring all of our variables with the var keyword, right? We would say var name equals Eric, right? We would use it for our objects, var obj equals, like a name, right? And the var keyword has been the de facto standard, the one way to declare variables since the dawn of time, since JavaScript was invented. But there are a few new ways to declare variables in JavaScript. We want to point these out now. The first is let. So if you do let name equals Eric, right? It's going to do the same sort of thing that the var keyword does, right? It's going to create a variable. We can shove things in it. We can change the values. We can use it as loops. Anywhere you can use var, you can also use let, with exceptions that we'll go over in here in a second. And then the second major thing is const, right? Const, if we put a name in here and we say const food equals apple, right? The difference with const is that it's constant, right? So if we go to, let's pull up this little page here, 127, right? And we go into our browser, so we can see that name. Oh, where are we at here? Name is a variable that says Eric. What was our food? Is a variable that says apple. But if we try to change the value of food and we say food equals banana, right? It's going to throw an error. It's going to tell you you're trying to assign something to a variable that is a constant, right? We cannot change the values of constants. Constants are excellent for things that you know are not going to change. Things like maybe like lists of configuration items, things like that. Like if you know, in Leah's example where she's building a card game, all those cards are never going to change. There's only king through 2 or ace through 2. That would be a perfect use of a constant where you can just declare, const cards equals, and then it'll be stuff like ace of spades, right? On down the list. Okay, constant is perfect for that kind of thing and should be used, right? One of the reasons that we want to use constant is that it makes it really simple for the browser to say, I know how I need to use this much RAM, this much memory to store this variable. Whereas a variable like name, for example, because it's interchangeable, right? Name right now says Eric, and so the browser's like, I can use 4 bytes to store this information, but if we change this to like applesauce, right? Now it needs 12 bytes, and so the browser has to constantly manage the size of variables that we're storing in the program. So use const whenever you can, whenever you know that it's a variable that won't change. Now, what is the major difference between let and var? Does anyone have any ideas?
I know it's something to do with the scope, but I'm not completely sure how.
It is exactly to do with the scope. That's exactly right. So that's another major problem that the browsers have had to do a very poor job of managing over time, which is we are assigning a variable, we're going to use it for some length of time, but the problem is when we use the var keyword, as we've learned, right? Let's say var funtime equals computer class, right? Funtime is a variable that actually belongs inside the window object. So it's actually window.funtime. So every time we create a variable using the var keyword like this, it's creating a new property inside of an object that exists up above. And so the scope of this variable inside of a single line of code like this is in the window object. And so as we create more variables, as we continue to build this stuff out, the window object continues to grow. And we can see now here, like, let's do object.keys window, maybe. Yeah, you can see there's like 211 things that are in this window object, right? That's a piece of code or a value that the browser has to control for the entire time you're on the page. So if you're building a product that is constantly changing, that you're going to be sitting on this page for a long time, like Gmail or a web client, something like that, this object is going to continue to grow, and it's going to continue to fill up with data. So I'm sure you guys have seen, sometimes you got 30, 40 tabs open, and Google Chrome or Safari is using up gigs and gigs of memory, right? That's because of this problem, where we've got more and more complex web apps that are constantly storing data and interacting with data, and they're using variables, in some cases defined like this, var, silly equals whatever, so that now object.keys has 212 things in it, and then 213, and so on and so forth. If we went to, let's just even take a look here. This is, their Google Slides thing. Let's see what they're doing in here. Let's do object.keys window. So we can see they've got 28,000 variables that are defined. 28,000. So to build an app of this kind of complexity causes a mountain of strain on the browser's resources and performance, because the computer is basically running a browser that not only has to process the HTML and the CSS and make sure everything looks correct, all of the interactivity that they've programmed in here, all these little menus that do things, are requiring us to write more and more complex JavaScript that put an extreme burden on the page, so that when we open up this tab, this tab is maybe 500 megs, which is ridiculous. When you think that like 10 years ago, 20 years ago when JavaScript was first invented, most computers had 120 megs of RAM. My first computer, I was like, oh, I got 256 megs. I can play any video game I want, right? And now this individual tab is using more RAM than that computer had. I mean, that's okay. So what the let keyword does is it gives us an opportunity to keep that namespace safe, and it allows us to not pollute things so much. So let's maybe look at a quick example. So we've been making loops like this for var I equals 0, I is less than 10, I++, right? So we're just going to make a simple loop, and if we do console.log I, right, we can come in here, and in the browser, we can see that it's printing out our numbers, but I exists. I is a value that is in that browser. We can change this to let, right? And if we type I now, well, it doesn't even show up, because it has been created inside the scope of this for loop, so it only exists here. So if we say window.I, right, that is undefined. So we've created a variable that is only used inside of one single use and is discarded thereafter, whenever the browser chooses to discard it. Any questions about that? In general, I mean, it's become common practice, especially in modern JavaScript development, to just use let everywhere, right? And to never use var. And if you ever need to put something in the global scope, if you need this to be in here, right, you might come in here and say window.I or counter equals I, right? And now we can say counter, which would have that variable that we had before if we needed it to be exposed externally. But in general, I mean, this is a silly example where we're actually just trying to count and discard the number. This is kind of the one benefit here is that it's discarded. Now, one thing to be aware of is that this also solves a problem that you may or may not run into before, right? So we got this loop. It counts from 1 to 9. But maybe, if we got a big JavaScript file way down, and there's, hundreds of other lines of code, right? Way down here, down at the bottom, we might do something like, name or age equals age plus I, right? Let's make age way up here at the top. Var age equals 10. Right? Because var I has been declared here, and that's a global variable, it is going to work in here. And so if I type in age, which I put as 10, right, you can see that the age is actually 20 because we've added it to this value that was created here. If we change this to let, right, now we're going to get I is not defined, an uncaught reference error, which is protecting us from making bad math mistakes elsewhere. Oftentimes, I'll come in here and reuse the same variable names over and over and over again, especially when it's in the context of we want to pick names of our variables that describe the functionality we're trying to do, and so we'll do things like function age maker or something, right? And it's like age, right? I'll want to make things in here that says like, future date, right, equals, new date, right? And this is kind of a silly example, but if I'm using a variable inside of a function, I might want to use this word in other functions as well. Using the let keyword here instead of var keeps me extra safe and makes sure that all of our variables never have any chance of collision or being overwritten outside of the scope of the functions, right? Does anyone have any questions about this? Const and let are going to be your new best friend, with the caveat being, if you're using an older browser, you're probably going to have to write var. Okay? We're all good about this? Cool. Oh, sheesh. Another cool thing that we have in ES6 that we haven't really talked about up till now is that we've been, to date, building our strings like this. So we wanted to do some crazy stuff. We have an age in here, and it says, var fun string equals my name is plus name plus, and I am let's change it back to var. My name is, and I am plus age years old. Right? And then we come in here and say console.log fun string. What do we have here? Next.
You're missing a plus.
Oh, thank you. Where am I missing a plus at? Oh, right here. Perfect. So we've been building our complicated strings like this, right? Using all of these concatenation things. We also learned that there was another way to do this where we could do var new string equals, my name is whatever name, and I am age years old. And we could use the array thing to say, join with a space. So that was the other way that we learned about this. So we could do new string in here. So those are our two ways to work with strings where we want to put JavaScript inside of it. Well, ES6 came along and said, this is kind of painful, and this is kind of hard to read. So they came up with a template system that is built into the language, and we don't have to worry about it. And the way we use the templates is we can say var template string equals, and instead of using a single quote or double quotes, use a single backtick, which is the character that's directly to the left of your one. And then here we can say my name is, and then we can put any variable we want in here between a $sign and curly brackets. We can say name, and I am $age years old. Right? And so now if I do template string, you can see that all those variables have been replaced. All right. Some other cool things that we can do with template strings is that we can do math and stuff in here, right? So again, I can come in here and say age plus 10, right? I think I have to put this in parentheses, but let's check. Yeah. So anything that's between these curly brackets that has a valid JavaScript expression can be used here, right? So we could do math, we could do string manipulation, any kind of thing that we want to do if it's between these curly brackets and a dollar sign in the front of it, it will work. Does everyone understand template strings? This is really powerful, and to me, like, this is one of my favorite things about ES6. Cool. Any questions? We're moving pretty fast on some pretty complicated topics, but
why is name crossed out on the code page?
It's the same reason that name was causing us problems way back on like week 2, is because name is a variable that exists in the window object already, and so it's confusing our browser. If I change this to like my name, right?
Okay, yeah. And then so template, is there an actual name for that, or is it just template string?
Yeah, it's called template string. So we could look up ES6 template strings, and it's going to walk you through all of those things. It's going to tell you the backtick thing. There is some more complicated functionality here in that you can make you can put a word before this that is a function, and let's see if there's an example in here. Yeah, like my tag. So you can create a function that does stuff with these template strings and then call it like this, which is like advanced functionality. I've never had to use this, and so I can't even think of like a real world example where this would be useful. Let's see if their example makes any sense. They make a function my tag. Any template string that is created like this is passed in as the strings is the first thing, the first argument, and then it's got like the variables themselves, right? So like person is the person argument. Then so each argument in this function, let's see if we can write one real quick. So like if I make a function, age maker, let's pretend this was a template string. So we'll say strings, and then we'll say age, and we'll say name, age, right? So if we console.log strings, that's going to be one thing. Console.log name, console.log age, right? And so we can come in here and say age maker right in front of this, as long as it's smushed up against this this backtick, and it's going to actually call this function and pass in the entire string, and then the variable name, and then the age. So let's do that and see what template string tells us. Yeah, so because we called template string like this, we assigned it to a variable. It's calling it immediately, right? So this is another way that this is like a complex function call. And you can see the very first argument is my name is and I am years old, which is 0, 1, and 2, and then it's got the variable Eric because that's what we put in that variable, and then the number 20 because that was what was in this expression right here. So it's going to take each and every expression. If I put in another one, right? Hello. Hello. All right, let's just put in 15, right? So now I would have a third one, which is like, some num. Some num. Right? Some num is not defined. What? Oh, it's right there.
You spelled some num different in the argument than in console.log.
Yeah, I sure did. Nice. That explains it. Some num. Fun. 15. Yeah. And then you can see that we have name, the age, and then some num, which if you spell it correctly, it shows up here, right? So it's just a really cool way. Where would you use this in the real world? I can't think of like a place you'd want to use it, but just know that you have that ability. That you can use these template literals to do something. Right? Oh, like here's a silly example, right? We could do age maker, and we could go into string, like because we can modify the other parts of the string that aren't a part of this. We can be like, maybe we wanted to use this for translation, and we could say something like strings 0 equals like hello, ich bin, right? And we could do some kind of translation. Wait, what would it call? Template string. We have to return all of this. Yeah. So it lets you build the string on the way back, right? So we can do return. So whatever you return here, you can do strings 0. name, right? And so now if we run this, template strings, it's returning something different than was there before, right? My name is Eric. So we're changing the information on the fly. So why did it not, string 0 equals, how do we spin? Let's do that. Oh, we could do it like this. Var, I'll put string equals string, hello, in. Right, so right, because we know the order of those templates coming in, we could use this for translation like this, and change it to another language, but still preserve the variables. So that's one thing you might be able to use this for. Cool. All right. Arrow functions. This one's wild. So up till now, we've been defining functions in this way. We'll say like function name, our name, and then we'll put in any arguments. So we'll say like whatever, first, last, and maybe the function says return. Let's use our thing. We'll do first, last, right? And maybe this function is actually supposed to be called like full name. Right, so we've got this function that exists that is called full name. And we say, full name, Eric, Harrison, right? And it returns that thing. That is one of the ways we've learned to define functions. We also have learned, this way, var, full name equals function, first, last, right? We'll do the same thing here. So both are valid. What ES6 has introduced is the concept of an entirely new way to write functions. So we can now say var full name equals first, last, arrow, which is an equal sign and a greater than sign, and then return. Let's paste it in because we got it on our clipboard. Right. So now full name, if we comment these out so we make sure that they're not running, right? This syntax lets us do some cool things, right? You can see it still works. But what it lets us do is that we don't have to use curly brackets for this if we're just trying to process one expression. So if we put it like this, right, with no curly brackets, whatever comes after this arrow is going to be the return value. So this is really good for like quick and easy math, quick and easy, like I want to just process the thing and have it be done. So if you're going to do something in one line, this syntax, full name, right? We run this again, lets us do things really quickly without a lot of hassle. So the syntax is the arguments in a parenthesis and an arrow equals plus a greater than sign, and then whatever is in here is returned. Now, if you put in curly brackets like this, right? You still have to provide your return statement manually. So you still have to come in here and say return whatever. You will see this this type of syntax used very frequently in some of the array methods we've been using before. Like, let's make an array here. Like, let cards equal ace, spades, king, spades, right? And when we're doing this kind of processing where we'd say cards dot for each, right? We know that this takes a function, right? And so before we were writing anonymous functions like this, and it would be like el, and we would come in here and say console.log el. But we would often do stuff inside this processing loop where we'd want to, maybe do something in here with the very like. Let's make these uppercase as an example. So we'd say like return el.to uppercase, right? And if we look at cards now, oh shoot, we have to cards equals. Oh, I overwrote it. Let's see. How do we do this? Well, I'll just log it for the sake of argument. Console.log el.to uppercase. Right. So this is the kind of thing we were doing. Console.log. So this is the kind of thing we've been doing pretty frequently. But what we might do, sort would be a really good one. Yeah, because that one returns. But what you might see is this type of syntax when you're working with these kind of iterator loops, where you'll just say el, and then console.log el, right? Which does the same sort of thing, right? So it's a shorthand way, and you're going to see this pretty common, especially as we start using some of the backend code, because this type of syntax has seemingly taken off as like the preferred way to write functions, right? I think it comes down to personal preference primarily. I prefer to write functions like this so that I know that I'm in a function, right? Function, full name, first, last. Because to me, this is very clean, that it lets me know, hey, I'm in a function. But when you're doing with a lot of modules and things that exist in NPM, when we start learning about the backend stuff, you're going to start to see a lot of things like this. And you might even see it in tutorials where they're talking about, I know Mozilla has almost completely switched over to this format. So if we went to some of their, let's see if we can find one of their examples. Let's just say, sort. Right? Yeah. So they're showing that as their primary way to use the sort function, which is the arrow method, right? So they're saying first el, that's using that. This is just, this is the same as this, but they prefer this type of syntax for whatever reason, stylistically. So being aware that those exist here, right, is important. So whenever you see this thing here, like, train your eyes to look for equal sign, greater than sign, so that you can recognize that this is a function that is expected to behave just like a function. Okay. Any questions about this this type of format?
So does that only apply with if there's just one return value? If there's more functionality within there, do you not use the arrow function? Like if you had...
You can use the arrow function. So the return method, where it's going to return whatever that value is, like here's a silly example, right? Like A, B, right? So if we wanted to build a function that would just let's do let square, or let multiply, right? Equals, and then we can return A times B. Okay, so we've created an arrow function. We've stored it in the variable multiply, and it takes two arguments, A and B. Okay, and all it's going to return is A times B. So this is like the shortest possible thing that we could do with an arrow function, like so 5, 10, right? And it returns 50. If you need to do more complicated things inside this mechanism, you still have to put it in brackets. Okay, so we can still make this multi-line. The only caveat being that as soon as you make it multi-line, right, like if we do multiply 5 times 10, right, it returns undefined because we don't have a return keyword in here. So you can still do things, like so we can do console.log about to multiply things. Right, so we can still do multiple things inside the function just like we have before. As soon as you throw in a curly bracket here, then you're responsible for choosing if it returns something or not. The shorthand syntax, when you do it without curly brackets, right, like this, is just a language syntactic. It's like a part of the syntax to make it really nice and easy for you to just quickly write like one line of code. And the perfect example for this was the one that they were talking about on Mozilla, right? So we've learned that like if we got numbers here, let's just drag all this in, right? So this is how we were sorting numbers previously. We would have an array. These numbers are in a crazy format. We've got a function A and B, and then we're returning whichever one is the lowest, right? So that was the previous thing, right? So if we console.log this, it's going to put them in 1, 2, 3, 4, 5. This shorthand version with an arrow function lets us do this really easily. We're going to just say numbers dot sort, and we say A, B, and we A minus B. Right? So that's doing the same thing, but with like, 6 letters instead of 30. Okay, and you can see that that's there. And then we can make this, B minus A. And now we've reverse sorted it. Go ahead, Leah.
Is there any reason to use an arrow function if it's going to be multi-line?
Yeah. Stylistically, I would encourage you that whatever mechanism you choose, stick with that mechanism the whole way. So if you're going to use arrow functions use arrow functions everywhere. There is nothing worse than reading, a 400-line JavaScript file where there's a whole bunch of different ways functions are defined, because then it makes it really difficult to, you have to context shift as you're reading. And so I think that's probably the biggest reason that has caused the shift that I was talking about, where most people are shifting to use arrow functions as their way to do things because they want to get this shorthand capability out of it. And so stylistically they say, if we're going to use this anywhere, we're just going to call all of our functions this way. So they'll say, var good function equals, like name feelings. I gotta stop doing this. My name feelings, food. Right? It's still a function. It's still exactly the same as if we written it another way, but if we're going to use this once in our file, then let's just use this in all of our functions. It also does some interesting things that we do need to be aware of, and we'll probably talk about that when we get to the next slide and we start talking about the this keyword. It behaves differently than how this works in other browsers, right? So if we did, let's just see if we can show this off real quick. So console.log this, right? Because we're in our global file, and we'll definitely dive into this next. This is the current object that it belongs to. So this is window, right? That's how all these variables are getting shoved into window when we create them with the variable keyword. But if we come in here and we say console.log this, right, this should do something different. I have to call the function, right? So let's good function, right? It's still in the window, whereas with this function method, right, when we create, so let's see, function, old function, my name, feelings, food, console.log this. If I call old, so new function, what would we call? Good function. Good function knows that this is in the window, but if I do old function, right, that shows it's in the window too, right? So that doesn't make any sense. I'll have to research that. I thought that this was changed based on arrow functions versus not. Maybe it's only in the single version. I don't know. We'll look at that when we get to this, which is going to be next for sure. I'll leave that so we can play with it later. But yeah, at its core, this method is really great for a lot of those function types that we've been looking at that are like array sort, all the ones that take a function as its primary argument. This is great because now you can have one function that returns in just a few lines of code, or just a few letters even in some cases, so that you don't have to write this big, long, complicated function. You can just do it all in one line. That's like benefit number one for this. Any questions there? All right, so that's arrow functions. We've also learned that each and every one of these functions, right? So like old function, or we'll use this as an example, rest functions, rest parameters, right? We also have an arguments object that exists in all of these. No, I can't see it, but that exists in all of these functions, right? So if I do console.log arguments here, right, we can see that there's a magical variable that exists inside of every function that tells us all of the arguments that we've passed to it, right? So if we pull up our thing here, I'm going to call this old function. So if I call old function and I put in, 1, 2, 3, right? We can see that when we console.log our arguments, it's an array that has each and every argument that's passed to it. This is one of the things that I recommended was if you were building a thing that can have a lot of different arguments, you might want to use this arguments object that exists because it's going to let you attach yourself to any value, right? So we know that we've got this function defined with 3 arguments, but we can put in 4 in here, right? We could say old function. Let's just I'll put in 5, 6, Steve. And this arguments object is going to capture all of them and use it from start to finish, so that we can see that we've got now we've got 5 elements in this. We've got 6 elements in this array, and it gives us things like arguments.length. This is a really good way to make code that needs like a few things, but lets you optionally provide extras. But what ES6 introduced is a rest parameter. So we'll say rest parameter. So if we wanted to do my name and then age, and then maybe we want to do everything else, we're going to put in an options value, right? So if we put 3 dots and then a name, let's just console.log arguments, but then let's also console.log my name, console.log age, and then let's console.log options, right? So let's clear all this out, and we'll call it rest param Eric 37, whatever, apples, pigs. Okay, so the arguments is still the same. It's still telling us that we put in 4 parameters. The 0th parameter is Eric. The number is 37. Then we have apples and pigs. But we can see that when we log out Eric and we log out 37, those were our 2 that we put a name to, and then it logs in an array that has everything else. So we can do things like this, where we say, hey, this is required, and this is anything else that comes in after it. It doesn't matter what you call this. This could be, cool stuff. Right? This is a variable as well, right? It's just creating an array for us that we can choose to use. This is excellent from a programming perspective because it lets the reader, so some future software engineer, whether it's you or a teammate, to let you know, like, hey, these 2 are important. This one is anything else. And so oftentimes when you're seeing and working with libraries that do a bunch of crazy functionality, it would be stuff like function get element, get L, right? So we might say like element 1, element ID, and we can say like other L's, right? So get L, we might say requires at least one argument, right? We might say something like if not element ID, right? So if nothing is passed in, we can return missing parameter, or we can return null, right? But maybe we do console.error must provide at least one element to return, right? So if element and ID is sent in, we would come in here and say if other L's dot length, right? So if there are things that are put in here, we're going to be returning an array. So we'll come in here and say element ID. Well, let's do we might do other L's dot unshift, so we can add it to the front, element ID, and then we would return. Let's actually make let elements equal an array, and we would do for let L ID in other L's elements dot push document dot get element by ID LID, and then return elements. Otherwise, we will say return document dot get element by ID element ID, right? So what we've done here, and maybe it'll help if we add some comments on this. We'll say like, write a function that returns either an element or array of elements. And we'll say, an element must be provided, otherwise error. Right, so that's what that's doing. So if we don't provide anything, we're going to return an error. And then if there is stuff that was put into here, if this length is greater, right, so, okay, we've gotten multiple elements, return an array, right? So we're just doing, we're looping through that existing array and then pushing in document.getElementById. Otherwise, if all of those things are not true, but we have an element ID, then we just return a single element, right? So we could see this here as, what did I call it? Get L. Oh, I need some elements, huh? Let's put some elements on our page. Let's say h1 ID equals something. Hello. Give ID equals something else. Hello. Do. Maybe p equals whatever, right? Right? So if I call getL with nothing, it's going to return null, and it's going to tell us there's an error. If I put in getL with something, it's going to return our h1. But I can also come in here and say getL with something, what do we call it? Something else. Whatever, and it's returning. Oh, no, I must have wrote something wrong in our code here. Let's check. Let's just debug this in real time. Console.log other else. Right. Good. Let's console.log LID. Oh. Because that's an array of. Right. So I was using in, but this is an object, so we have to use var whatever of the array to get the value. It was giving us the index before, which was incorrect. So now you can see we've returned an array that has 3 element references in here, and each of these element references is one that we can operate on with regular DOM-specific JavaScript code. So we could say get L something, 0, right? Dot style dot, background color blue, right? So that's the kind of thing that you're going to do when you're working with a lot of JavaScript libraries that are pre-built. And as you start to build functions and functionality for yourself, ones that jump to mind is Leah's card game or Estrella's story writing engine. You're going to want to write functions that you can use for yourself, that you can reuse over and over and over again. And so that, this is the great kind of thing, before this REST parameter option was available to you, you would have to come in here and do the same sort of thing, but with arguments. Right? So you'd say like, if arguments dot length is greater than 1, right? You've got to intentionally say, I care about the first parameter, so I need to make sure that the value is bigger. This just lets us write cleaner code and lets other developers who are reading this understand what your intentions were when you wrote this function a little bit better. Does that make sense? Dot, dot, dot. 3 periods in front of a variable is going to take every single thing that was included as well and shove it in here in an array. Any questions about this? We're going to use this in other places as well. This is the REST parameter. Perfect. That takes us to spread operator, which is very, very similar to the REST parameter. All right. How can I describe this correctly? let's, all right, let's do this. So let's say we've got an array, right? And this array is a bunch of numbers, and it'll be like all of the ages of so let's say, oh, shoot. Let's do var ages equals, 10, 12, 11, 37, right? So we got a little weird family here with a bunch of kids, and we'll maybe come in here and say, like if we wanted to, let's see, we wanted to write a function that was like, sum all the ages, and we were like, x, y, z, right? Great. So we got x, y, and z here, right? We're expecting 3 parameters, and it's kind of like what we were using the spread function for, or the rest parameter for, but we're going to use it in reverse. So maybe we just do return x plus y plus z. Let's take this out. Right. So right now, sum all the ages. This function, all the ages, takes 3 specific arguments, right? It's expecting us to send in 3 separate values, so it'd be like, what do we call it? Ages. Ages 0, ages 1, ages 2, right? That's going to give us 33, all 3 of those put together. But what we can also do is we can use the spread operator in reverse and do ... ages, so that we don't have to tell the function where we're doing. So it's like the rest parameter, except the rest parameter was on the definition of the function and is going to shove things into a specific object, but but doing it like this is telling the function, hey, I've got an array that has values in it, put it into each individual index. And we can kind of, let's see what happens when we run it here. Yeah, it doesn't work in that context. So this is basically just exploding that array into the correct slots of the function. So if you know, and the cool thing is if we have extra ones, right? So like ages dot push, let's say 37 again, right? So now ages has 4 things in it, but the function takes 3, right? It's going to ignore any variable that does not go into that, right? So if the function is expecting 3, and you've got an element with 4 or 5 or 6, this will let you just pass in the ones that matter, and it's going to go in order, like so 0, 1, 2 as the array indexes. Does that make sense? Cool. Object destructuring. All right. Cool. So there's another thing that we can do in ES6 that is useful pretty often. So we've got ages, right? What if we just wanted, the first 2? Up until now we've been declaring, it was similar to what we were just talking about where we did ... If we wanted to get the first 2, we'd say like var age 1 equals, ages 0, var age 2 equals ages 1, right? We've been working with it like that, so we're making age 1, age 2. What object destructuring lets us do is do it as a part of the assignment, right? So we can say var age 1, age 2 equals ages. This should work. Age 1? Yeah, perfect. So we can put, because we know this is an array, we can say, hey, variable 1 is this, variable 2 is this, and if we put in a third one, right, we do age 3, age 4, right? Age 1, age 2, age 3, age 4, undefined. So we can do all of the variables that pull out individual pieces along the way. Do you see how we're doing this here? And now if agent, let's take this out. This lets us in one line grab little bits and pieces out of this that we want all in one spot rather than doing it line by line by line. And this works for objects as well, right? So what's a good example for this? Maybe, oh, okay, I got one, right? So like var user is an array or is an object. We'll maybe put in here like ID is 55. Name equals Eric. Age 47, right? So that's our traditional object. But we wanted to get like the ID and the name out of this. We could do something like var ID name username equals user. Let's see what this does. What did I call it? ID 55, right, as expected, and username is going to be undefined because username is not a value in this thing, right? But we could replace this with name, right? And now name will be defined. Okay, so this works on objects as well, but if you're using it with objects, you notice the syntax is different. We're putting it in curly brackets here instead of square brackets with arrays, and then we have to use the name of the key that we're pulling it from. Okay. Any questions about this? There's another cool thing that we can do here with object destructuring specifically, in that we can put in default values. So we can put let's say website equals google.com, right? So in here we've got ID is being pulled from the user, name is being pulled from the user, and website is being pulled from the user, but it has a value here, right? So what happens is if I type in website, it's putting in google.com because this object doesn't have it. But as soon as I put in a value here and I say website, and I say ericharrison.info, right? Now when I type in website, it's going to say ericharrison.info. So this is a really cool way, especially when we start doing database stuff or data model stuff, or what we learned last week when we were setting things in session or local storage. You can be working with objects like this and set up your expectations of what the values are going to be. And if the user has not provided that in one of the objects you've stored, you're still going to have a value that is useful. And a great example of this is like, right, if this is our user object, this is one thing you'll do pretty frequently, where maybe it's like avatar, right? You got like a profile picture, and it'll be like, images dot whatever, right? Image.jpg, right? So that's like my profile picture. It's got my head in there. A lot of times you'll have a user that has not uploaded a picture, and so this will actually be blank or not present, right? And so you might want to come in here and say that the avatar is actually one of the placeholders, right? Like avatar placeholder. Like something like this, so that the user object will always have a value there, so that when you're working inside of your HTML, you can come in here and say image source equals, and then ID avatar image. Let's show this off as a silly example. Let's say we'll just do get L. What do we make this? Avatar image dot attribute, set attribute source, right? Source, and then we'll put in avatar, right? So if this user doesn't have an avatar, it's going to load a generic picture or whatever, I'm sure you guys have seen websites where it's got like a gray background with a white silhouette. They're using this kind of functionality where they say, hey, the default is this, but if the user has an image, then it would overwrite it. And we'd say avatar equals, whatever. I don't know. Let's see if changing it to image form. Yeah, so this is my actual picture, right? But if this was not provided, let's see what happens if this says null. Okay, it's still broken. So this default does not take into account some of that the value is set, but has a null. What if we make this undefined? Maybe that'll. Okay, so undefined is the one you're going to want to use if you're expecting this object to have a value, but the user hasn't put in one. So undefined is the thing. But if you've got something like null or 0, it's actually going to try and load. I bet if we inspected this image, it probably would say, yeah, source is null, which is not what we want. But this, so this is called object destructuring. And we can do this with arrays as well. Useful shorthand for sure. Any questions about any of this? We've gone over a bunch of stuff. It's all stuff that we've already learned, but it's just new syntax for how to do it either quicker or slightly cleaner, depending on how you're trying to write and express yourself in code. So there's nothing really new here, other than new capabilities for how to cleanly express your intent. No? We're all good? All right. It is 5:57. Let's take a short 15-minute break and come back at like 6:15. Good? Sweet. All right, cool. Thank you for sharing, Leah. That was excellent. Thank you for showing us what you're working on, Estrella. That was cool. And Andrew, excited to see your progress tomorrow. All right, so the last little shorthand thing that I wanted to show you guys and make you be aware of, because you're going to see this pretty frequently in code, and it's also really useful. I use this all the time. It's called a ternary operator. Ternary, ternary, like that, right? And what a ternary is a shorthand way of evaluating a conditional, right? So we've learned before that, like, if true, right, do something here, that is true, else do the false. Okay? That's how we've been doing things before. But if we wanted to do this in a short way, and we want it to be quick and easy, there is another method of this, right? So let's just say console.log true, console.log false. Right? And we can see that, hey, this is true because the true was happened. If we change this to false, the false has happened, right? You understand this? This one's you guys should be pretty comfortable with this by now. The ternary shorthand looks like this, and so we can do true question mark console.log true colon console.log false, right? And now we can see true operates there, right? We can put false here, and now we'll see false. So the syntax for this is expression question mark. That tells you, hey, we're doing a ternary. And then we'll say, you know, something true, and then colon, something false. Right? So this is an excellent shorthand. If we wanted to do, like, here's a great example where you'll do this inside of a console.log. You might come in here and say console.log. Oh no, what am I doing? Console.log, and you'll come in here and say, you know, true, question mark, yes, no, right? And so now you're going to see that this little shorthand here has returned the value true out of this expression into console.log. Or if this was false, it would say no, right? It's kind of like when we were talking about user up here. So like if we checked user.avatar, right? It's undefined. We could do if user.avatar, right? And then you know, this is like the full syntax way of doing this. We would do, you know, console.log. The avatar is, you know, plus user.avatar, right? Else console.log. No avatar set. Right. But what this lets us do with ternary is that we can come in here and say, like, you know, var user avatar equals user.avatar question mark user.avatar, or you know, what was our placeholder image? Copy the image address. Right? And then we can see user avatar equals the placeholder image, because user avatar is a false value. It's undefined. So this is called the ternary conditional syntax. It is exactly the same as an if and an else. Now the one like weird bit here is, you notice that, like, this syntax is, you know, true question mark and then something true, right? Like yes, no. If we wanted to do if else, and we wanted to have extra stuff like else ifs, we would have to do a second one inside of our falses, right? So we can do no, or we could do like true, true, or like, let's say like user.avatar, right? User.avatar or false. Let's change this to false. Okay. So you can see that this one says, is it false? If it was true, it would say yes, but it doesn't. So it says user avatar, and then it checks it again. So we can chain a bunch of these together, but the one, like, I would urge you not to use ternaries for things that are complicated like this, because you can see that it like makes it really hard to follow the logic. If you're going to go multiple levels deep like this, just use an if statement so that we can follow it along, and we could say like else if or else or whatever, because chaining negative values like this together, you could just end up with some crazy nonsense that's really hard to follow logically. But what this is excellent for is things like this: console.log user.avatar question user.avatar no avatar set. Right? So simple shorthand to let you just evaluate a value, and you say, you know, this is the true, this is the false. Okay. Another thing to note is that just like with arrow functions, when we were talking about the ones that automatically return, we cannot add complexity here. So I can't come in here and say, console.log fun, right? Because we cannot put multiple lines of statements in here. This is a single expression that is evaluated based on whatever this is, right? So if it's user.avatar, we can't do two things. We can just do one. Now, the exception to that would be we could always, if we wanted to do 2 lines of code here, we could write a function that had those 2 lines of code, and we could be like show avatar and comment, right? We could put a function in here. But in general, this is kind of wild. Ternaries are really good for doing one simple check between like a yes or no and returning that result into an existing function. Any questions around ternaries before we move on? And you can always look this up: ternary function JavaScript, right? Ternary. And the good thing is, the reason we wanted to focus on this as a shorthand is that this type of ternary syntax is going to be the same in just about every other programming language you'll ever use. So you'll see this if you're programming in C++ or PHP or Perl or Python. A lot of them have this exact syntax, right? And here's a great example. Like, if this is member function, they get a reduced price, otherwise they get the full price, right? That's the kind of thing that you'll use ternaries for. Okay, condition. Cool. All right, on to something cool. All right. This. Am I still console logging? Yeah, let's take all that out. What else? Yeah. Okay, cool. So we've been playing in a couple different places. One of the ones that we've looked at earlier when we were playing with some of the elements was the this keyword, right? And this is a reference to an object's instance. Okay, what does that mean? Let's unpack this a little bit. So we know that everything in JavaScript is an object, right? So, one of the ways we learned to write an array was we'd say like var r equals new array, right? That's going to create an array type of object. And each of these types of object is referenced by the whatever we assign it to, right? So if I do var r equals new array, r in here is the instance of that array. So the instance has specific properties like length, right? If we make var r2 equals new array, right? And we say r2 dot push, neat, right? r2 dot length is different than r dot length because those are different instances of an object. It means that, like, think of it as like a concrete thing, right? Like, if you go to the grocery store, they might have a bin of apples. Each apple is a unique thing that is all going to have similar properties. They're all going to have a skin, whether it's green or red or some yellow weird apples. They're all going to have a core with some number of seeds. They're all going to have a stem. Okay? each instance of that object is unique to that object, and they share the same properties, right? We even call the properties in JavaScript and in programming. Like, the things that describe that object exist as a part of that object. But when we're inside the object, right? If I'm inside this apple, as an example, we use the this keyword to reference those properties because this is that apple. So let's quickly dive into developing our own object, and we'll show that off, right? So maybe that's a great example, right? So I can say function fruit, and we'll say name price. Maybe we're building a shopping mall, and maybe we'll say seeds, right? And then, right, this is we're going to learn about what these functions are in general, right? This is nothing special. This function can be called anything we want. We can call it lowercase fruit, but for the sake of argument, we're going to call this uppercase fruit. This is similar to what Leah had written in her code when she used the class keyword. We're going to use this function as an object constructor, right? So we're going to come in here and say this.name equals name, this.price equals price, this.seeds equals seeds, right? So we've created a function called fruit. And this function, because we're using this in here like this in here like this, what an interesting statement. Because we're using this here, it's kind of indicating to us that this function is actually going to be something special. And what that something special is that it lets us reference this function as an object constructor. Maybe we'll let's make these kind of, come on, make these side by side so we can see it at the same time. So I can come in here and say var apple equals new fruit. And I'll say the name is apple, the price is $1, and it has 8 seeds. Right? So now if I type apple in here, you can see that it is a type of thing that is a fruit. And we know that it has a name of apple, a price of 1, and it has 8 seeds because we have referenced it in here with this. Okay, so it's saying this specific instance is that. Right? If we just run apple, or if we just run fruit by itself, right, without the new keyword, if I say fruit, apple, 1, seeds 8, right? It returns undefined because this function does not return anything. We could also come in here and say return this. Okay, so now it's going to return itself. And so now if I do fruit, apple, 1, 8, right? It's going to return the window object, right? Because this is what is calling that object, right? It's not until we use the new keyword that it creates a brand new instance of this object, right? So if we did var banana equals fruit, and we call it banana, $2, and it has 0 seeds, right? Banana is still the window object, right? Because this, when we don't use the new keyword, does not create a new instance. Okay, so let's just run that again, but with banana being new, right? So we can say new fruit. Now if we type in banana, it becomes a fruit, and it has name banana, price 2, seed 0. Is everyone tracking along? So this is very closely related to new when we're working with objects specifically. You're going to create the thing with new, and then once it's created with new, this has changed to no longer be just window, right? If we typed console.log this up here, we saw that earlier, console.log this, right? That's going to return window. It's going to log window for us. But if we're inside the fruit and we say console.log this, okay, well, this is not going to log anything because it's going to be attached to the window. But if we were inside of a function that was in here, let's show that off just real quickly. Fruit prototype who am I? And we'll say that's a function that doesn't take anything. All right. So let's say var banana equals new fruit. I can do banana dot who am I. Oh, I didn't actually log it. Console.log this. Wait, what? Oh, I have to create it first. You can see that this reference, this inside this special function, which we'll learn about here in a minute, references the instance of this object that we created, banana. Right? If I made another object and we said var apple equals new fruit apple, right? If I do apple dot who am I, it is the apple version of itself. So we're going to use this all over the place to operate on this specific element, this specific object. Where did we use this before? It was on one of our we were looping through events, right? So remember we were doing what's this? What do we call this element? ID, right? H1. So when we did var h1l equals document dot get element by ID something. Well, let's make them classes, right? So it can be an array. No, I don't want to show that off. That's a waste of our time for right now. But you're going to use this in the context of HTML pretty frequently in some of the functions like get element by class name when you're looping through these elements, where this will be a reference to the current object, the current HTML element. So we were doing things like last week we were saying this dot style dot and add a let's do it with add event listener. So we'll do document dot document get element by ID something dot add event listener, right? Click, and we say function, or event, right? EV. But inside the context of this add event listener, when we bind a function to an element based on a click or on load or whatever, this is that element, right? If we console.log this right now, it is going to be if we click on the element, right? It's going to keep attaching to this element. That's how we were able to shorthand here and say this dot style dot background color equals purple. And so when I click on here, now we made it purple. Because this, in the context of HTML, in the DOM, in the document object model, this is a reference to the element that had that event fire on it, right? Because this is a function that is telling it, hey, whenever this click happens, this element is doing a thing, all right? And so that's another place you're going to see this. Any questions with this? We're going to use this in a few different ways. Go ahead, Leah.
I have a question about the like the function you made earlier. Like, what's the difference between that and a class?
Yeah, good question. How can I unpack this in a way that makes sense? Okay, so classes, for example, is ES6 specific. That is a new language feature that did not exist for the past 20 years. JavaScript was originally created to be a prototypal prototypal object-oriented system, which is unique in programming. Most programming languages use a class-based system where they say like class, fruit, right? Kind of like your example, and it would say like name, whatever the syntax is for JavaScript. Where you're still using the new keyword. New is still creating an instance of that object, but JavaScript, because it started out so tightly coupled with the browser, they decided that a better way to develop this programming language was to use prototypes. So they started off with the idea that like an object was a function, the constructor was a function, and so we were going to write it like this, and then we were going to put in the properties of that function in here like this, and then every object would have a special prototype member that said whenever this prototype existed, right? What is actually happening is prototype is not attached to here, right? So if we go to Apple, oh wait, I reloaded. So if we look at Apple here, if you've looked at any of these objects, you notice that there's a special proto object in here, and this is where all those extra functions are being shoved. They're not actually stored in the object, but when we call who am I, the object says, I know that my object has this prototype function, or this prototype value. I'm going to go look that up first, right? And so we used to write all of our classes and all of our functions, all of our objects in here as like, function, whatever, meat, right? It'd be like name of the meat, price, And so we do, this dot name equals name, this dot price equals price. And then we would go in and define all those extra prototype stuff. So that'd be like meat dot prototype dot animal, right? So it might be like the default is cow, right? Fruit has already been declared. Where do I have my class here. Right, so if I do var steak equals new meat tomahawk, and then 35, it's steak. It has two elements in here, tomahawk and 35, but it also has a prototype that says animal cow, right? So every object of this has, dot animal. And so this is how all of the JavaScript is working under the scenes. Like when we write a string in here and we say var name or var my name equals new string Eric. My name has a whole bunch of extra methods here that we get, like length and then anchor, bold, char at. They're not actually on this specific instance. They're the prototype of this instance, so that each of these instances can inherit them from this global definition of classes so that we can add functionality, right? It's a very powerful way to write object-oriented code, because we can write a very small and tight definition of like what is expected out of us, and then write a whole bunch of, right? So way up at the very top of JavaScript is probably a function object, right? And it probably just says this dot toString, right? Equals function, right? Like return, something, right? And so then it's got object dot prototype dot keys equals function, right? And so it'll say like for var I in this, it would say return this, or return I, right? So all of this has been built up, and then we will come in and say array, function array, and we will tell it that it inherits from object. So from top down, all of these things have the prototype properties of the objects above it. And so it's an interesting way to build software, but it vastly differs from every other programming language so much that in ES6 they intentionally added functionality to just syntactically appear like we are Java or C or PHP, so that it's less jarring. But you're still going to see prototype stuff occasionally, especially in the context of HTML pages or older libraries. So it's important to be aware that, like, behind the scenes, it's still a prototype-based object-oriented language. Go ahead, Leah.
So I don't mean to get too far off the main topic, but I've seen prototype countless times, and it's always been in the back of my mind, like what is prototype? I still don't really know what it means.
Yeah, it means kind of exactly what the name implies, which is this is the prototype of that object, of this class. And so if you think of, I'm going to use the word class here because even though it's kind of incorrect, like if we assume we're defining what a fruit object can be, like we were talking about apple, right? Each apple's going to have a skin. It's going to have some amount of juice, some amount of pulp, or whatever they call the apple meat. It's going to have some seeds. It's going to have like a genotype, like this is a red delicious or this is a whatever. We are going to use that. We can write a class right now that says like this is our apples, right? So we'll say like function apple, right? And we'll maybe say like name, whatever, genotype, skin, color, seeds. Right, so each apple that is created with the new instance is going to have different values of this, right? Genotype might be the same for all of them. You might have 1 million red deliciouses, but if you have, a Gala apple or one of these other brands, right, that would be different. But then the skin color is going to be different. And then the amount of seeds that they have is all going to be individual and unique, right? Even within the same, like red delicious might have between 4 and 6 seeds on average. There's no way to tell. But what we're doing is we're saying, hey, this is what an apple is, and we'll say like, this dot name equals name, this dot genotype equals genotype, this dot skin color equals skin color, right? And so we're really just defining, hey, when we call this the first time with new, we're going to pass in these parameters to set it. And then we'd say this dot seeds equals seeds. But then what prototype does is that it lets us attach, rather than defining this individually for each one, right? Because we could also come in here and say this dot taste, right? And we'd say this is a function, and we'll say return yummy, right? This is actually including the function here in each and every one of these objects. So if we do new apple, let's do var a equals new apple, name apple 1, red delicious, we'll say red and 5, right? So we've created an apple. Okay, it actually has the function taste in here. Okay, what prototype lets us do is not attach this and put it in the prototype so that it is inheritable, right? So we can go apple.prototype.taste equals function console dot, let's return it. Return yummy. Right? So that now, if we look at our A, it does not have that function in there defined as one of its main properties, but it does exist in the prototype. So we can say a.taste yummy. And when we, in a few minutes, we're probably actually going to take a look at these, kind of as we come back from break, for how we can set up inheritance models that use this prototype mechanism to make it really easy for us to build and develop and deploy complex data objects and complex models with interactivity, right? Because up until now, we've mostly been using objects as object literals, where we'd say like user, and we'd come in here and say like ID, 5, name, Eric, age 37. This is an object literal, right? We're mostly just using this to store data. But when it gets to object-oriented programming, we want to have these things interact with each other. And so our objects are a little different than this, right? If we wanted to make this is a great example, right? We're using an object literal here that is user, but we might want to come in here in our program and actually build a user object that we can use as a data model. So we can come in here and say user, and it'll say, name, or maybe we'll do ID, age, or name, age. Like we'll say this dot ID equals ID, this dot name equals name, this dot age equals age. All right. So right now, how we have this defined, user is these three things. Okay, or we'd have to. So these three things. Okay, this is functionally identical for us to say like new user, right? So I can come in here and say Leah equals new user ID 6, name Leah, and I don't know what your age is, so I'm just going to say you are 6,000. Right? So now Leah is a brand new object of type user that is here. Right? Let's check one thing, right? So we do type of Leah, and it's going to say object. So it's still an object behind the scenes, but now we know that this is a user object because it is created from that prototype. And the prototype has a constructor that says it is the user function. Okay? Go ahead.
So there's no use for the rest parameter within a prototype, right? The little ... or
yeah, I mean, you might, so here, I mean, here's a great example, right? So
or would that just not really work?
it could. You might come in here and do ... options, right? And so when you're using, if this was really a library, we might come in here and say this .options equals options, right? So we know we want ID, name, and age, but we want to get everything else and put it in an options object. And maybe user is a bad example of this, but you'll do this in library development pretty often. Like when we start learning about, communicating with servers using like XML HTTP requests or AJAX, we'll put in like the URL as the first parameter, and then everything else goes in here. But we're still got it as an object that would be like new, it would be function Ajax, and it says URL options, right? Like that. And so in this example where we have user, right? If I say var Leah equals new user 6 Leah 6000, and then cake puppies, right? Leah, right? Like, we've put those into an array here. We want to save them and do something with them. Maybe it's just a list of our favorite books. It's completely up to us what we want to use that for, but we have that available as an option to us. Another thing that we used to do before even this REST option existed, we literally wrote our classes like this, where we'd say like, we're going to take these three things, and then you're going to pass in an object of options. So we would define our code to be like this. It would be like, right? We come in here and say, food is cake, and pet is puppies. So now Leah would have those things defined as an options object. We would do this all the time, and we're gonna see, especially when we get into the JavaScript communication stuff. We'll probably still use this method over using the spread operator, just so we can have things be named. What happens if we put in? Let's see this. If we put in an object, it's going to put it into just options, right? Yeah. Yeah. So the problem is, if you put it in with the spread operator, it shoves it into an array. So you have to have array 0 as whatever. Without, you still could do this, but maybe you'd want to come in here and go like this, so that Leah will have the options array nicely formatted. Yeah, I think if I'm building classes like this, I would almost always err on the side of just doing it like this, unless it was like literally going to be a list of items. Like maybe maybe food or apple is a great example, where it's like I'm going to define a bunch of other values in here that we want to use as an array, but it really comes down to, do you want everything to be an array or not? Is what, to me, the root of the issue, because you can always I don't know. If you need an array, use the spread here. Cool. All right, what else? All right, it is 7:05. We've been kind of at it for a little while, dealing with some heavy stuff. When we come back, we're going to talk about actually using classes and data models like this to provide a little bit of inheritance, so that we can define something like define a food object, and then our fruit inherits from food, meat inherits from food, right? And we'll walk through that kind of thought process and how we're going to do that with both prototype, and then maybe we'll if we have time today, maybe we'll dive into the class syntax as well. Okay, so it's 7:06. Let's come back at 7:20. 7:20. All right. Really, for the rest of the day, we're going to talk about a bunch of different object-oriented concepts, and I really want to spend a lot of time here and play with this because there's a bunch of ways to do this, and there's a lot of pros and cons to each, and a lot of them are going to come from experience. A lot of them are stylistic in nature. Like, there's no right or wrong answer. We'll probably take a look at ES6, introduce the concept of classes. All right. So the reason we're going to create objects in our code is so that we can abstract concepts and data into things that are actionable. So, in the example that I gave earlier, which is like we're trying to recreate a real-world object, or we're trying to recreate a real-world scenario, right? So a good common example of this would be like var user equals. Let's do it like this. And we might create a user object that is user ID, email, password, and And each of these things that we're putting in here, right, is a part of the data model for this user, right? But the user on its own isn't useful unless we're encapsulating specific actions in this object as well. So we might have a user.prototype.login, right? That is a function, and it would say, email pass, right? And we're check to see if the password is valid. If it is, set a cookie, right? And then we'll do a log out, which is user.prototype log out equals function email or user ID, right? So if we're logged in already, we would log out the user, and it would be all tied to a specific instance of, if you're the visitor to the page, you're the only user that exists, and so you are an instance of a specific user, and so you can log out, you can log in, you can change your password, you can update your email address. Maybe the user is used to purchase something. The user object, because we've created an instance of it where it'd be like me equals new user, right? We can pass this me object around to other functions. So if we were building a shopping cart, or if we were building a video game like Leah is, we might track all of my wins and losses on me, and so it might say something like, we maybe come in here and create a user.prototype record score function, and it saves score to server. And so me, every time I win a game, it might be me.record score, win, something like that, so that my object that exists for me, my instance that we created with this new keyword, has all these functions that I can do to myself that are encapsulated entirely within my object. I'm not creating anything in the window. I'm not got a bunch of global variables floating around. Everything related to the user is attached to me. Is everyone kind of tracking that? It's like, this is the use case for object-oriented programming. Everything we've done up until now has been non-object oriented in nature. We've been writing, there's a name for this, but it's slipping my mind, where it's like, it's declarative, right? So each line of code is doing one thing, and we're going down the list. We'll say like, user logs in, check password, right? We're going on down the list, but we've been using functions to make this less declarative by saying like, user logs in, rather than writing this line of code here one at a time on down the list. We're saying, call login function, right? That is functional programming, to a lesser degree, where it's different from declarative in that we're not going line by line down the code. We're saying go line by line down the code, but call this function. Well, object-oriented programming takes that to another level and says the data object itself has functions that operate on the data object, right? So all of those properties that we're including, in fruit, for example, this fruit has a name, this fruit has a price, this fruit has seeds. And so when we're going to call more functions on this, like we might have a, fruit.prototype.remove core, right? So we've decored the fruit, right? Which says, which instantly says, this dot seeds equals 0. And maybe if we had a weight attribute, it would be like this dot mass is equals this dot mass minus 100 grams, right? So we are creating functions that operate on the specific object itself. Now, just because we're creating functions that operate on this object does not mean that we can't write functions in here that operate on other objects as well, right? We might have, an instance where we've got a fruit that needs to, like, if it rots, it can infect other fruit in the basket. So we might have a, fruit.prototype.rot, and it knows about stuff in the global scope. So maybe there's a basket object somewhere that has all the fruit in it. So it says like basket, basket dot fruit dot for each, and we loop through here, and we say, hey, the rotting value has gone up by 1. A deck of cards is a great example. Leah's got a deck which is made up of cards that are in here. So the deck might have function that sorts the cards, like shuffle cards happens on the deck, and it reorders itself. And each individual card is an object that is a member of that deck, right? And so let's do that, because I think cards is a really good analogy here. Let's take all this stuff out. Right? So we might have function deck, and we'll put in a number of cards, and maybe we'll have a second one which says like include jokers. Right? So if we have a deck, 52 cards are in the standard deck, but it's 54 if you include the 2 jokers. But we'll say this dot number of cards equals number of cards. This dot, we'll check include jokers. We'll say if include jokers is true, right? We'll expect this to be a Boolean. Maybe we'll give ourselves a little note here, and we'll say, Boolean, right? We can put a comment up here, so it lets us know, hey, includes jokers is just a yes or no. So we'll say if include jokers is true, because it'll be undefined if we don't pass it in here, so it'll be false. But if I put in true, then we say this dot number of cards equals this dot number of cards plus 2, and we'll also say, maybe we have a property that says this dot has jokers equals true, right? So now I've got this deck class. Let's move this over so we can look at both at the same time, right? We've got a deck class, and I can say var cards equals new deck. I'll go in here and say 52, and we'll just say false, right? We don't want to include. Oh, did I already declare cards? Where did I declare cards at? Cards. Oh, I made it a constant at the top. Weird limit. Gosh. Cards. Good. Okay, cool. So now cards is a deck, and it has 52. But if I came in here and said cards equals, new deck, and I put in true, right? It has jokers. Right, now cards, you can see has 54 cards, and the has jokers property is true. Okay? And then the other things that I would probably want to include in this deck class, let's make this a little smaller, is, there probably needs to be a cards array. So I might come in here and say this dot cards equals, array. And then I would maybe, if I've got a constant up here, const cards in deck, where I've got my actual array of cards in here, I'd say something like ace, king, queen, and so on, right? I'm not going to type all these out. This dot cards might actually say cards in deck, right? I'm getting this variable that is a constant. We know it's never going to change. And then we said, if this, maybe I'll set this up here, right? So this cards in deck, and then I come in here and say, oh, even better. Check this out, right? So this is one way we could have done this. I could say this cards in deck, and then I come in here and say this dot push, Joker 1. This dot push Joker 2. Right. So if we call this dot push. Oh, this dot cards dot push. Where does this come from? Why is it so small? There we go. Better. And so if we look at cards here, right, we've got a deck. The cards array has those cards in it, and we've pushed in Joker 1 and Joker 2 as a part of this thing. Okay? And then what we probably want to do is, right, we've got this deck object here. We might want to come in here and say that there is a function called cards, like this is a class here, and we say, card name. Maybe we do suit. Well, let's do value suit. Right? So we do this dot value equals value. This dot suit equals suit, and then we do maybe we do cards has a prototype. Oh, let's make this card. Card has a prototype of toString that is a function, and it returns this dot suit plus of plus this dot value, right? So if I make a new card, I can say var card my card equals new card, and we say king clubs. I can do my card dot toString. I'm going to say king of clubs. Okay, so we've created a function that is going to operate on the values and properties of this object specifically to it. So if we were building cards in deck, right, we might come in here and say const suits, and we're going to come in here and say clubs, spades, hearts, diamonds, right? So as a part of this cards, rather than just saying this cards equals cards in deck, I might actually come in here and say for var suit of suits, and then we'll do another one that is for cards in deck. So say var card value. I'll say value because we already have a value of cards in deck. We'll say instead of pushing this onto the array like we were doing before, let's take all this out. We will actually call this.cards.push, and we'll put in new card suit, right, value suit. Okay. So if we call var cards equals new deck 52, we'll just call it 52. Cannot read property push if undefined. Did I take it out? I must have. Yeah. So we do this cards equals array. Okay. So now when we look at cards here, we've got a card made up of a bunch of card objects that we can have other functions on. Each one of those cards has a value and a suit. And if we go to like let's pull this out here. So we can do cards, you know, 3. What? Cancel. Cards 3 is that specific object that has a toString that gives us spades of ace. Oh, I got it backwards. Suit. Ace of spades, right? So now we have objects that we can do things with, and so in Leah's example, she could, we could fold these. We could, this might have a value in here, right? The value that's actually calculated. We can put like this dot score value is, 10 by default. Then we can check, hey, ace might be 11 or ace might be 1. All those types of things. We can encapsulate all of that logic inside of the object that it belongs to, because each card can have a value. Each card can have a name. Maybe we put in, this dot image equals, whatever, some link to an image somewhere. We might put in this dot card color, and that maps to, is it red or is it black? Red. Okay. So that's kind of like the why. This is why we use object-oriented programming, is because it lets us make a close approximation to a model of logic that matches the real world, right? Any questions? Leah.
Like the few things I'd heard about object-oriented programming before this was that it's used too much and that it's not good. Do you know why it has that reputation?
Yeah. Yeah. So this is treading carefully on, because these are mostly just opinions, right? Way back in the day, in the earliest days of programming, from the 50s on to the 80s, mid to late 80s, everyone was using declarative programming. We would write a line of code. That line of code would do a thing, and it would be something as simple as move this value to here, add these two values together, and print it to the screen. We were very much like line by line. Basic is probably the most famous version of this programming language, where literally it starts on like line 10, and you'll go in and say like print hello, right? And then it'll be like print world, go to 10, right? That was like the most famous version of like a declarative example, and I have that tattooed on my arm as like a joke, as an homage to the olden days of programming. You started reading from the top and you went all the way to the bottom, line by line by line. And the only thing you ever had to worry about was like if anyone ever said go to, it was jumping you to a different place. When we started, the big leap forward here would be subroutines or functions, which is I'm going to come in here and say this is the function, do something, or like say hello, right? And in our syntax we have curly brackets. We would put all of these lines of code together, and so then now we have a way of structuring our program so that we can be more expressive. So it could be like log in, right, is the first line, and then it says say hello, right? So we can put logic in libraries and in files and go crazy. Well, I want to say the 80s, but maybe it's the 70s even, right? So a former language was C. A man by name of Björn Strusup, he's like Swedish or Finnish or something, was a famous, he created C++, and at the time C++ was an extension of C that was really designed around this new model that he thought was powerful, which is let's turn everything into an object, okay? And so C++ was C with objects. And it let us do stuff like this, where we'd have card, deck, this can be a thing, right? It lets us reuse our code in a way that can match or mirror the real world, right? The problem is, as soon as that kind of hit the mainstream, then everyone thought, oh my gosh, the only way to write code is to write object-oriented programming. And so it became your way is old and bad, our way is new and good, and it became a bit of a language war, but both sides are correct, right? You can write very clean, imperative, code that kind of goes line by line. You can beautifully structure it with functions. A lot of our operating systems were built prior to this concept of objects. So, like, the world existed before object-oriented programming, and kind of, I think the inflection was like mid to late 80s, early 90s. We really see this go to, it's probably the worst incarnation, and this is purely what I saw happening at the time, was that languages like Java came around and said, C++ had objects, and that's great, but we're going to make everything an object. And JavaScript kind of is a more modern, like that was we've said everything is an object, right? It's because behind the scenes, everything is an object. Everything inherits from some base class somewhere that exists and says, like, an object has keys, an object has values, right? And so, the prototype of that carries forward into an array and carries forward to that into the other thing. Java is a great example in that you will have lines of code that are like 40 lines deep, that it's like the square class calls the rectangle class to do operations on math to spit out a vector, right? And so it can get ugly and it can get messy, and if the programming language or if the individual developer does not do a good job on writing and being intentionally clever with how they express themselves, it can get really hard to work in. Now, what was the first part of your statement? You said you heard it was bad or that it was overused.
Yeah, mostly overused.
Yeah, I mean, it can be overused for sure. But I would also point out that, like, we have been writing our code up till now not using any classes, not using any objects for anything other than, like, a place to store data. But behind the scenes, everything that you've been touching on has been an object, right? So your arrays, when we make an array, it's an array object that has properties and, when we say var r equals new array, right? Or if we say var r equals array, right? Behind the scenes, r, like, let's do this over here. R equals new array, right? R dot push 5, right? If you look at R and we expand this out, you'll notice that it has a prototype thing just like everything else, and all those functions that we take for granted that we like to use on this array exist because they exist because array is an object that has some constructor somewhere that has given us these functions. And that's one of the things to me that makes JavaScript such a powerful language. And a great example of this is we can add new functionality to to the web page by adding things to the prototype of elements, right? So like HTML element, right, is the default object of each and every element that's on this page. So we can, in theory, say HTML element dot prototype dot Eric function equals function hello, right? And I think this will work. Let's see. So if I do document dot get element by ID, what do we call it? Something, right? That is an element, and I can now call dot Eric function maybe. Didn't work because it's not. Let's see, type of. Let's call this one. I have to get like the right type of thing. Oh, it's just object. So we could do object dot prototype dot Eric equals function console.log Eric is neat. Right. So if we do this, Eric, it should work. Yeah, it did. So I've just enhanced JavaScript in our browser by giving myself a function that now exists on each and every one of these things. And the power of this is that, this Eric function right here, it has access to this, right? So I can do this.style.background color equals purple. Okay. So now if I call document.getElementById something Eric, I've just made this purple. And I've just added this to the entirety of HTML. This is what a lot of our libraries and frameworks are doing, whether it's jQuery or Prototype.js, any of these cool libraries and frameworks that we're going to want to use. They're going to operate on each and every one of these elements and give you new functionality. And they might give you animations, they might give you cool effects, they might let you update the content of the page magically by saying document.getElementById something watch for changes on the weather channel, right? All of those things that we might want to build into our product, we can do this entirely through JavaScript and completely change the way it works. Now, can it be abused? Oh, 100% yes. We are responsible for the code that we write. And so I have used libraries and frameworks that have just made me want to pull my hair out because they attach magic things to everything. It causes unintentional side effects and behaviors. We can have collisions in the language where if we've got this function Eric in here, and two different libraries try to make this function exist, which one actually runs just is going to depend on which one was defined last. So it can be abused, it can be misused, but it should be a tool in your tool belt because behind the scenes, everything is an object, and everything is an object using this mechanism. You can write very clear, very precise, easy to understand, easy to read code, going line by line, and a great example of this is the stuff Andrew and Estrella are working on, where they haven't been using classes or anything fancy yet, but you're going to get to a point where it makes sense to, have your data kind of reflect the functionality of the real world. So I think there's probably some truth in mixing and matching, using a little bit of, use classes where it makes sense, use functions, objects where it makes sense, and where it doesn't, you can write one line of code, document.getElementById, something else. That's the thing. Yep. .style, .background color. Just green. We don't need to bring functions into this. We don't need to bring anything. We're just saying, I'm just going to write this one line of code that does the thing. So it's kind of like dealer's choice here, right? Write whatever makes the most sense for the problem you're trying to solve. And the other caveat being that when you get to your jobs and when you're in the real world and you're in your working environment, they're going to kind of tell you what they expect of you. Your actual request might be write a class that has these properties that does this thing. Any other questions? Yeah, I think the fact that we can add additional functionality onto every type of object or element is one of the most powerful things in JavaScript. And that's what I love the most about the fact that JavaScript is prototype-based instead of class-based. We have classes now in ES6, maybe we'll take a look at that now, that make it look nicer, but just being able to go in and say any type of object of this, like I can come in, like we got an apple or a fruit, right? Did I delete these? Yeah, I probably deleted them. Oh, let's just do card, right? So card exists in here, right? This is a function that exists that we can make a class out of. I can come in at any time and say card dot prototype dot add card, right? And now I've added more functionality that is safe. You know, it's each one of these is different. And the cool thing about this is that it's like the style of this makes a lot of sense to me visually, right? Like this is our main constructor, right? Class constructor, where we can define these are the properties that go in there, and then we can come in the prototype and say, these are all the functions we would put. So it keeps things like very distinct visually and lets me know like, hey, this is different. So I'd say like, toString method of cards. And so as we add more functionality in here, I would keep them separate, right? We can also come in here and, as I kind of showed you off, right, we can do like this dot, calculate score. Can be a function, and we could say, right, this dot value or score value plus 10. We can just like return this. Our fake code is breaking our code. Right? And so now if I do, var a equals new card, whatever, clubs, 6 clubs, right, A, right, it has a calculate score function in it, but I think it looks cleaner if it's inside the prototype, so that all those methods are there, and that the object itself just has the values that we're operating on. But it's completely stylistic. If you're building a library that is like a whole bunch of functions to do animations or fancy magic on the HTML page, maybe you write an object that's just full of functions. Like the math object is a great example of this. Let's see what happens if we look at here. Yeah, like they've got a couple of values up at the top, e, pi, but then it's got a whole bunch of functions inside of it because they want you to know this math object is providing you functionality. Like in every sense of the word functionality. It is giving you functions. But for objects like our card thing, I really like the cleanliness of saying, these are all the values that I'm operating on, and then all of our functions are going to be in here in a prototype. So they're still able to be accessed by every member of that card class, but we don't have to create a bunch of them. Cool. What other questions? Leah again.
So when like you make a new object with a function on it, or like with like a prototype, does it like create a copy of that code, and would that like take up unnecessary space or something, or?
Not necessarily. No, not really. You don't really think of the space as the problem. I mean, behind the scenes, it really is allocating space. But if you look at like a new deck, right? Like the object itself has this prototype object, proto, that has all of that extra information anyway that's already associated to it. So don't concern yourself with the space here. I want to say that like the last time I cared about this was way back in the early 2000s when I was learning about this in the first place, and there were a bunch of things that were true at the time, which was like it was faster to go with the prototype because the prototype would like look at the values. It was like a different object that existed in window for all of the objects and would look into it, but that's probably not true at all in reality. It really just comes down to like, to me, it's like the things that you're working on in that object should be in the object inside of as like a property of like this, and the things that are happening or operating on those objects should be in the prototype. And the prototype is also interesting because that's what brings us to inheritance, right? So maybe it's a good segue into inheritance. All right. There's a better way to do this in ES6, but like there's a bunch of different ways to do this in ES5 and earlier. Right? So let's make what did we have before? We were doing like define a food object, define a fruit object, define a meat object, right? So there is a relationship. A meat is a fruit, a fruit is a food. And so you can use object-oriented programming to like define the parent object that has all of the properties that you care about, and then define new objects that inherit from that and take advantage of those existing things, right? So we can come in here and say function food, and we'll say like name, right? Great. And we say this dot name equals food or name, right? And maybe we need a food dot prototype dot toString equals function, and we'll say return I am a food, right? Plus this dot name, right? So this is kind of like the start of building a object that understands its world around it, right? So if we say var apple equals new food apple, right? Apple is a thing. It has a toString method where I can call it, and it says I am a food apple, okay? But then we think, hey, we want to make this even more complex. We know that apples have seeds, they have a color to them, but we want to still say like, it's got this dot name, it's got this function that says I am a food, right? So maybe we come in here and we say function fruit, and we say name, we say seeds, color, right? All the things that we care about for food. And so we'll say this dot name equals name, this dot seeds equals seeds, this dot color equals color, right? And then we want to come in here and say like, hey, but anything that food has, we want this to have too. So we can say fruit dot prototype, if we can spell here, equals food dot prototype. Okay. So now a fruit is going to share all the resources of food. So if I say var apple equals new apple, or new fruit, I say apple, 5 seeds, red. Okay, we can see that apple has those properties, but apple also has toString, which is going to say I am a food apple. Welcome back, Selena. So, and then we can do the same for meat, right? So we can say function meat. We can say name, right? We can say type, right? So we'll say this dot name equals name, this dot type equals type, and then maybe meat has a prototype of maybe we have meat dot prototype dot cook temp, right? Where it's a function that returns medium rare, right? So a meat can have its own separate entity, but we still want to have, we want meat to be meat dot prototype equals food dot prototype, right? We still want it to have toString. We still want it to have all the things we defined on our top level thing, food, right? And then maybe we come in here and we say, okay, we've got meats, we've got fruits, those are the special ones. But then we just want to come in here and say like, what's another vegetable, right? And vegetable can be empty because it doesn't need anything special. We just want to say vegetable dot prototype equals food dot prototype. Right? So we can create this like entire structure that inherits from a single base item. And then maybe what we do is we say like, fruit is a great one, but we care a lot about apples. We're apple crazy, right? So we're going to make another object that inherits from fruit, which inherits from food. You're kind of following along? How we can build a complex structure of relationships between one and the other, but they can all inherit, each one of these. If I make a meat now, right, like a var steak equals new meat steak, and then we say it's a, this is a ribeye, right? Steak still has toString that it got from food, but it has its own properties that are unique to it, like type, and it also has a steak.cooktemp that is going to, tell us, hey, you're up to this degree, it's medium rare right now. Okay. Does everyone understand kind of a little bit about inheritance and how this stuff kind of works? Okay. Now, let's take a look at how ES6 has made this a little bit interesting. So let's look at ES6 classes. I haven't used these very often because I don't like object-oriented programming that much. ES6 classes. So Leah was using this in her method. All right, so let's take a look at this as an example, right? Class rectangle. It has a special function called a constructor. That exists already, right? So when we have function fruit here, this is a constructor function. So when we call it, it is letting us put in our arguments and put it out, right? So we can come in here and let's just make a new one, right? We'll say ES6 syntax for classes. Okay, and we'll say class, and we'll give what's another food that we haven't modeled out yet? Ice cream. We'll do ice cream. Right. So this is class ice cream, and it has a constructor that is name, flavor, temperature. Right. And so we, just like with how we've been defining it up here when we create our main function, this constructor is a function, and it's gonna, we're gonna say this dot name equals name, this dot flavor equals flavor, this dot temp equals temp, right? So that's the purpose of the constructor, is to construct the instance, right? So we're gonna do all of our setups and that sort of thing, and it returns an instance of a class ice cream, okay? So if we came into our page here and we said var ice cream equals new ice cream, and we say what is it, Rocky Road, chocolate with nuts, and the temp is maybe it's 0F, right? So IC now has that same object, right? It's got that information, but you'll notice it also has a prototype, right? We could just as easily come in here and mix and match our metaphors, and we could say ice cream dot prototype dot toString, or we could just say like melt equals function, and we could say return it's melted, it is melted. So if we make the same thing, ic.melt, right, it is melted. Because even though we have classes now, they had to keep the language the same, and so it's a syntactic nicety that provides that functionality. Is everyone kind of following along? We've seen it in a bunch of different examples. This syntax is doing the same thing as this syntax, just in a different style, right? So if you're used to working in Java, or if you're used to working in PHP or Python or some of these languages that have like a strong object-oriented programming background, now you can write stuff like this instead of writing stuff like this. What other stuff can you do with their classes? All right, so you can do, good. So some of the other ones is getters and setters, right? So each one thing that's different with these classes is this is new functionality in ES6, is that they have a get function and a set function. So we can say get name, right? And we'll say return this dot name. Or maybe we'll say something different so we know that we're not referencing the right thing. So we can say get, cool name, right? So even though this is a function now, if we run var ic, I can do ic.coolName, and it's returning Rocky Road even though I haven't called it as a function, right? ic_coolName is not a function because it is a getter. You see this? Even though the getter is a function. This is one of the weird things about like object-oriented programming that I am not, this personal preference, like I don't like this style, right? I would rather write my functions to be like meet.prototype.getName, and I know it's a function, and I'm going to call it as a function, and I would say, return this dot name, versus this fancy version that says get and then puts the name in there, and it looks like a function, but I can't call it like a function, right? Oh, I have to create IC again. get name. Right here. Equals function. Right? IC.cool name is a getter. Okay? There's also a setter, I believe. Let's see if that works just like we'd think. Set cool name. How do we do setters? Set? Is that a thing? Maybe not. Maybe they just expect you to set it correctly. Other programming languages, if they're going to use a getter like this, a get method, they'll also have a set. But you know, I guess in the JavaScript version of classes, they just expect you to set your thing by like name equals whatever. Right. And so now IC.coolName returns that value. So I don't know why you'd want to use that over the other. It just comes down to preference. If you're used to working in a programming language that uses that type of like a strongly typed Java versus C, C++ in some cases, you'll see this kind of pattern. And if you want to feel comfortable and know what you're doing, this is an option as well. A good example of this is maybe like, I can't think of a good example because I don't use this all that often. Any questions about this type of structure? We can also make extra functions in here. You'll notice that inside the class we're inside of brackets here, or curly brackets, and each individual function or property in here has its own curly brackets. None of these are separated with commas, so it's like its own weird syntax. And then if I wanted to make a function that was like instead of ice cream.prototype.melt, the way to do this in this would be to come in here and say melt, and then we would say return it is melting. And so if you make ice cream now, icy.melt, it is melting. So stylistically, just like with everything else, if you're going to use one of these over the other, make sure you use the same thing everywhere. It is going to be very annoying if you've got a class defined like this and you have functions defined like this that you're using as classes. So pick a style and go with it. If you're working in your job, use whatever style the rest of your team is using. That's the correct way. But there's nothing wrong with either version. They're just different styles of expressing those concepts. Any questions? There's also, I wanted to show you one thing that is cool about this version. So you remember this is kind of like janky in that we're saying fruit.prototype equals food.prototype. Well, with this model, class ice cream, right, we can do this class, popsicle extends ice cream. So this syntax to me looks quite a bit cleaner. Go ahead, Gregory.
Well, the extends ice cream, is it adding to with the class of popsicle?
What was the question?
What does the function extend do?
It's basically the same as what we were doing up here, where it's saying this meat inherits stuff from food. So when we write this like this, I mean, this to me is the only reason to use this for me, for this personal. Like, this is not, there's no objective truth here. I just like this version better for this specific reason, which is I can say class popsicle extends ice cream, and it's much cleaner to me as a representation rather than like this old-fashioned janky way to like create like inheritance. So when we say class, I can come in here and say, let's see if this works by itself. Bar, dilly bar equals new popsicle. Right? Dilly bar. Okay, perfect. I needed to give it some values. Let's say, dilly bar chocolate. And say 0F, right? So dilly bar, right now, it has nothing extra in here because we haven't defined anything, but we've created it as a class. So all the things that existed in ice cream exist in here. So we can do dilly bar dot melt, right? And then we can enhance this popsicle class by writing extra stuff in here. So we can say like, stick type, right? And we'll say return wooden, right? So now the popsicle dilly bar dot stick type has extra methods that the ice cream class did not have. So we can still come in here and make ice cream, right? Where's our ice cream, right? icy.stick type is undefined because that doesn't have that function in here. Okay. So to me, this syntax is super, super clean if you're going to write a whole bunch of objects that inherit from other objects. So if I was going to build a maybe a store and I have a whole bunch of products in here and they have prices and each product can be, maybe it's an apple, maybe it's a fruit, maybe it's a vegetable. This is how we used to write it. And this can get kind of weird when you want things to inherit from other things because you have to just remember there's like food.prototype dot whatever. I would probably choose this for defining real world things. And the only time I would use the dot prototype method would be when I want to change things on the page. So like, in the example we showed off where we said, hey, every H1 element gets the ability to have a secret Eric function so that when we're working on it, I can make things purple. Any questions about any of this? Object-oriented programming, specifically in the context of this, right? We can do, like, melt is a good example. If, all right, let's make a temp. All right, so let's say if temp, this dot temp is less than 0, return it is melting. Else, or over 0. Else, return it is frozen. Okay. So now if we create a dilly bar or an ice cream and let's change this to a number. Right? So we'll say like 15. Icy.melt. It's melting. If we say icy.temp equals -3, -2, it is frozen. Right? So we've created an object that knows its own temperature. It knows what it's doing, and then we wrote a function that checked that value and did something special. So to me, this is like really powerful and lets us express ourselves in interesting ways. Right? We can say, icy is a pretty dumb name for a variable, but what it lets me do as a software engineer is I can write stuff and say, var ice cream bucket equals new ice cream. We can say chocolate flavor. We could tell its current temperature. We can say like right now it is 0 degrees. And so now when I'm writing my code, I can say if ice cream bucket dot temperature is less than something or other, right? Like we can now be very expressive in how we write our code because we're creating objects that have functions and have properties and have values and things. All right, it is 8:10. What would we like to go over in more detail? Is there any examples we'd like to look at or play with? Gregory.
Can you go everything?
Can I go over everything?
Yeah.
Yeah, that's what the video's for. You'll see it tomorrow.
I think the rest parameter, I didn't like. I get what it does, but I would like to see it like used in a practical way.
Like this one when we first looked at it. Did this like this one? Are you talking about this one?
Yeah, that's right.
Yeah. So this is like the most practical way of this, which would be like, I'm gonna take either one or more options and do them, right? Because it's stylistic, right? The other way we could have written this before ES6 came around, right? Like get L. Let's maybe write it together with the old way, right? So let's just do let's copy all this over. Okay. So if I was going to make a function that would let me get one or more elements, and a lot of libraries will provide this as like a $sign function or something like that. They would come in here and say function get L's, right? And they would just provide nothing. Okay, and so then they would come in here and say var L's to get equals, maybe we can start from arguments. We'd say like if arguments dot length, right? So we'd say like if there are arguments, return a reference to the element for each one. Okay. So like one of the reasons we might want to do this, right? We know we can do document.getElement by ID something, right? We get that. If we put in something that's wrong, we get a null. So maybe we want to have it so that like if the array returns nulls, we just want to strip those out. So if we, we want it so that like we're going to pass in any arguments that we want, any elements that we like. We want to get multiple elements. We want it to be an array for us. But if there's nothing, we don't want a null because then our code might be trying to do something on null, which is going to throw null values. So maybe we'll say get else will take one or more elements, IDs, and return an array without nulls to each element, right? So this is the old way, right? We would say if arguments.length, because arguments is our magic array here that has all the arguments, right? So if there's something, okay, otherwise we can do return false, right? Maybe we want to return an empty array because that's really what we're trying to do here. Like I'm going to put in some elements and I'm going to either return an array or nothing, right? So if I come in here and I say if arguments.length, I would go for var I equals 0, I is less than arguments.length, I plus plus. And then I would come in here and say var L equals document.getElement by ID arguments I. Right, so it's going to turn that into my thing. And we probably need to have a var elements equals an array. Okay. And so I'm going to come in here and I'm going to say, all right, we got the element. That's going to be either the element itself or it's going to be a null. But we want to check that and say if L elements.push L. Right? So if there is a value there, put it in there. Otherwise, skip it completely. Okay? And then when my loop is done, I'm going to return elements. Or maybe what we can do is, because now we know we've started elements as being empty, and we're returning it if it's good, I can just come out here and say return elements here, right? It's going to either be empty or it's going to be full of good elements. So now I've written a pretty nice little argument, a pretty nice little thing here that gives us one or more. But you remember, so it returns an array without nulls to each element. But what if we wanted to have it so that if, well, let's test this out first. Right? Get L is not defined. Oh, where are we calling get L? Get L. I used it somewhere. Yeah, right here. All right. All right, so we have get Ls now. So if I do get Ls and I put in something, right, we're going to get an array that has the element in it. If I put in something else, right, we get that. We get 2. If I put in something that doesn't exist in here, ASDF, I had a bunch of junk, we still just have 2. So that function is working correct on its own. But maybe we want to make this a little bit cleverer, and we say like it's going to return an array without nulls, return an element if it's the only argument, or return an array of elements, right? So this is a more realistic use pattern. So we're going to come in here and say if arguments.length, right, we're returning an array, and then we might want to come in here and say, we can use a ternary for this. We can say if return elements.length is greater than 1 elements, else return elements 0. Oh, that'll break. Let's not do that. All right, figure this out. All right, so we'd have to write even more complex code. We'd say if arguments.length. Yep. Maybe we'd come above this and say if arguments.length equals 1, else if arguments.length, right? So then we come in here and say we want it to return. Do we still want it to return an empty array if there's nothing there? Do we want it to return false? Maybe. I don't know. Depends. It's up to us. Let's try both. So we'll say return document get element by ID arguments 0. All right. So now if we do get else and we say something, it's going to return just that element, not an array. We put in 2. We could say something else. Right? Yeah. Now I've got an array again, but we can also put in something that's wrong here, like ASDF. Right? It's still returning it as an array because to us on the front end where we're writing and using this function, I think I might have multiple elements coming back, so I'm going to expect an array, even though the array is empty, because I might have been using that inside of a loop. So I might do something like, var else is, it might be like this. So I might be like, for var I might do it like this. So like var else equals get else something else gibberish, right? So I don't know how many of those elements are going to exist on this page, but I know I'm going to want to loop through them. For var I in of else, right? So I can do console.log I. Oh, maybe we want to make this L, right? Because it's not an iterator. And so you can see I've now console.log my thing. Now, this is the old way, where we're actually working on this argument's length. So the only reason you'd want to use the spread operator is if you wanted to be more clear about your intentions. So we've got this code. Let's rewrite it using spread. So function spread else. Right? And we'll say like element ID, elements, element IDs, right? So it's going to be one or more. Stylistically, I can read this and say like, oh yeah, because when I'm in here writing my code, spread else, right? It's going to tell me that, right? It's a part of that syntax that's popping up in the editor. Whereas if I come in here and I just say get else, right? It's saying any, right? So it's not telling me anything about what it's expecting. So it's really for the coder to understand what is expected of this function, right? We can write this either way, right? I can come in here and say var elements equals, let's just recreate this really quickly. And we'll say, all right, we'll say if elements IDs, let's just say if not element IDs, right? So if there's an empty array there, we know we're in the 1 version. We know we've just got one of these. And so then I would say return document.get element by ID, element ID. Else, we can just do the same code we were doing before. And then return elements. So the only thing that it gives us syntactically is that when I'm typing code in my editor, spread else tells me that I can take, something, and as soon as I get to my next, as soon as I hit comma here, it tells me, oh, element IDs, I can put more in here, right? But it works the same way, regardless of what method you choose. And we could have done the same thing without this, right? If I do, if I'm here, right, something. Oh wait, let me use the other version, right? Element ID, right? So if I get else, right, this is still going to work, this get else, because we're still tapping into arguments. But the only problem is if I'm in here typing and I say get else and I start typing, you have to just know that those extra arguments are there as implied. That just, you get that by magic, right? So I can type in something, and as soon as I hit my comma, you can see that this is bolded. It's saying args. It's telling you, hey, anything else that you put in here is getting dumped into args. But to me, if you use this method, it lets you describe what you're expecting a little bit more easily to the developer. Does that answer your question?
Yeah, it does.
Cool. A lot of the things, we've looked at like 10 or 11, a bunch of examples over the last 5-6 weeks of like there's 3 or 4 different ways to do things. The only thing that makes one version right or wrong is how clear you're able to communicate to future developers. I've said it a few times. It's like we're writing code for ourselves and for our team, not for the computer. The computer doesn't care what the code is. We're writing code. I mean, like the spread operator is a perfect example. This literally just exists to let us know that when I'm in here typing and I'm in let's get spread. When I'm in an IDE that has this kind of syntax highlighting, spread else, right? IntelliSense, it's telling me what the arguments are, what the parameters are, so that I know what I'm expecting to put in here. And it's even telling us it's going to return an HTML element or an array of HTML elements. That's really cool. I don't know how VS Code is doing that. It must be smart. That's neat. So it's telling you it takes an element ID and any number of element IDs, and it's going to return either an HTML element or an array of HTML elements. So let's see if this, what if we always return let's see this. So at spread else, we can do elements dot push get element. Let's copy this in here. Elements. And if we come in here now and we type spread else, yeah, now it's saying it's always going to return an array of elements. So it's telling us in our IntelliSense. Visual Studio Code, maybe it's one of our plugins, is smart enough to like actually read this JavaScript and tell you what's going to happen. That's pretty cool. I don't know how it does that. Neat. So that's the only reason to use those kind of things, is if you want to be like extra clear in your intentions of what you're doing. And that should still not like stop you from documenting these correctly. Like we haven't really talked about documentation, but there's like a doc block, right? Where you'll see stuff like this. It'll be like spread else, element ID, right? And then you'll say like returns array of element references, right? So this comment is providing the same information to a future developer as me typing spread else. And see, this doc block comment added that information here too. We could put in like a story. Hello, this is a funny story. Don't put in funny stories, but the editor is smart enough to add all that extra context in here for us, so that we're able to like work in IntelliSense to be easier. Any questions? Andrew.
This is kind of moving forward, so if someone else has another question, I don't want to segue the topic, but my question is, or just maybe I need a little bit of explanation. I'm trying to understand, so once we create a prototype or a class, I'm trying to understand, like, let's say we have a form or some sort of input, and we want to get an instance of that prototype. How would we, I'm having a hard time wrapping my head around how I would gather, like a username instance of the user prototype, and then maybe like store that to like, an array or object, like what we would store it to, and how we, would we be grabbing that by ID from the forms?
Yes.
And referencing the prototype, or
yeah.
Okay.
So let's use that as that's like a really good example. So let's tie this to our HTML somehow, right? So we've got an element in here, and let's just make a form real quickly. Form action equals whatever index.html method equals post, and we'll maybe just do on submit equals return false, right? Just so it doesn't submit on us accidentally. All right, let's do label, name, email. Right, we'll say that this user is like email and password, right? So label, and we'll do input type equals email, name equals email, ID equals email, and maybe we'll say this is email, this is our login form, right? And we'll say autocomplete equals false. Okay. We'll say label, password, login, pass. Alright, cool. Let's take off autocomplete, we don't need this. Alright, so we've got our little form here. We need a submit button now. Let's say input type equals submit, value equals login. Okay. Alright, oh, what did I do? Clicked on something. Oh. Alright, cool. So we got an email. I type in me@harrison.info, password, right? Login. This, because I turned this to return false, right? Doesn't do anything. But let's say we wanted to, like, we have a user object, right? So that's the first thing. We know that we have a user. We don't necessarily care about the form information, but we're going to define a user. Did I make one in here? Do I have to delete it real quick? Let's see. User. Let's just look for user in here. All right. Take that out. Take this out. No other. Good. All right. So let's ignore all the other stuff we've been doing. But let's say we're on a blank page. We want to, like, we've built an object. So let's say we got a class user that is its own thing, and it's got a constructor, and maybe it's email. Right. The only thing we care about is, like, the user is created with an email address, right? So on default, like, this user hasn't logged in yet. We haven't filled out this form. We don't care about it. So we'll say this dot email equals email, and we'll say this dot ID equals null. Alright, cool. But we have a couple of functions that we might want to do, which is login, right? And so maybe what we have to do here is get email and password and check to see if this is correct. Okay, fine. So we got our user. We're going to start writing our function now. We might come in here and say document. Let's do var email equals doc. Let's make this let, so that we're not creating variables all over the place. Let email equals document dot get element by ID. Email. What do we call it? Login email. Yeah. Email login. We made it backwards. Of course we did. Pass login. Right. So we'll say email login dot value. Okay, so we got that. We're gonna get our pass. We'll say document dot get element by ID. Pass login dot value. Right. So if we run this right now, nothing happens, right? Because we haven't instantiated our user. But what we would probably do in the real world when we're actually building products is that we're going to assume every time the page loads, we're going to create a user object, right? Every time I log into every time I touch this page, a user object exists, and maybe by default we could say maybe it's an empty, or maybe we say, like, it's guest, right? So we can just make this, right, guest, and maybe we don't even have a constructor, right? So var user equals new user, right? It's just blank. So now this page is loaded. I have a user object. It has nothing, but it has a login function that when I click on this, it's going to pull the values out of here and do something with it, right? So okay. Check it's correct, right? So we get the login. We get these two values, and we just say if now. In the real world, you're actually going to send this off to a server somewhere. We're going to learn about that later this week. But we'll say if this dot email, or we'll say if email equals me at harrison.info and pass equals password, right? Good login. Store it. Right, so we'll say this dot email equals email. We probably don't want to store the password anyway. We just want to use it to verify. But then we'll say, like, this dot ID equals 1, and we'll say get the ID from the server. Right? So when we log in with email and password, it's going to return the ID, it's going to return my full name, all my profile information. So let's assume that we got a whole bunch of stuff in here, and we say this dot full name, we say this dot first equals Eric, this dot last equals Harrison, right? So if we log in, so if I put me.EricHarrisonInfo, and I put password in here, if you assume that I have clicked the login button, I might say user login, it's called that function, and now we can check our user object, and we can now see that all of that information has populated in here because I logged in successfully. Now, how we would tie this into things is that we probably want to have login bound to that function, or to that button. So maybe what we do is we say in our constructor, because that constructor is called here, when we say new user, we might say document.getElement by ID. What did I call that button? No, I didn't call it anything. ID equals login button login. I might say button login dot add event listener click function. Oh, I might just say this dot login. All right. Well, let's just in this case say user dot login. This dot login. Now there's a problem with this because we haven't talked really about binding this, right? So this dot login is going to run in the context of this login button, so this is going to fail. So let's see if this me at EricHarrisonInfo password. Yeah, so if I user.login, yeah, so user is empty right now because we did not bind this, but what we can do is we can bind this. So we can do me at EricHarrisonInfo password, click login, and if we look at user now, it has done that function. Now what bind does, because we were talking about this earlier today, but we just like briefly glanced over it. When this event listener is called, right? If I was to come in here and say console.log this, okay? So this login function exists right now. And when I log this is bound to this login button. This, in that context, is the input itself, okay? But there is a function that exists on objects called bind, which when I run it like this, if I do this, right? When I click on this button now, it is bound to the user object. So even though I've clicked this button, I have said, hey, your actual object that you belong to is this other object, right? So that's what lets this work for us. And if I type in password, it logs me in. And if we could, we can come in here and say else, right? Like if the password is wrong, console.warn invalid password. So this is, like, Andrew, to get back to your original question, like this is the real world representation of like how you would build things to interact with pages, right? Like the HTML itself is the least interesting part of being a web developer to me. Like unless you're really interested in front-end development and you're in here making things beautiful for your users and doing stuff all the time, like you're going to spend a couple of days making your beautiful golf cart prototype, and then you're going to spend all your time in the back end writing objects, tying it to databases, and adding functionality, right? This is the job of programming to me, unless you're purely front end or purely something else. So you're going to write objects like this. A user is a great example because almost every product you're going to ever build is going to have some kind of user representation. You're going to have an ID for the user tied to the ID in the database. You're going to have an email address. You're going to have a password. You're going to have to check to make sure the password's correct. You're going to want to store, like, every time, for you and your golf app, you're probably going to want to have like a class game, right? So like every time you'll click new game, it's going to give you a brand new 18 holes, and you're going to track score by hole. And then as soon as you're done with the game, you're going to store the entire game to the database tied to the user. So we might have like, we might have a function that's like get games, right? And get games knows that it belongs to user ID, whatever, 1 or 19 or 4,000, however many users you have, and it will do something like query database for database for all games played by this user, right? And then you'll have a function that is like, save scores, right? And so that you'll say query database to save my scores, so that as you're building this object, as you're building this interaction into your product, all of your interactions exist under the object that you're writing them in, right? We could, to talk about what Leo was talking about earlier, we could write this code without using objects at all. But this is a really clean representation of what is happening in your real world. Like, if you're building a golf app, as an example, like, a game has 18 holes. Each hole has a certain number of shots, and you maybe want to track certain values in the shots as well, like, class, hole, right? Hole. And the things that you might care about in this hole is like, longest drive, right? So, you hit it 192 yards, like you're going to store 192. If you hit it 193 the next time, 192 would update because it knows that it's a different thing now. Or maybe that's tracked in the game, right? So you might have class game that has holes, and that you're tracking the longest drive of the game. But each hole will have a drive that is that number, and it'll say something like, drive 500, 400 feet, right? And if this number is bigger than this number, then you would increase that value. And then at the very end of it, you're going to say, save my game, and it's going to take that game up. Maybe save scores takes a game, like an entire game object, and shoves it into the database correctly. And there are some databases, like session storage or whatever, session storage, or even local storage, right? Some of these let you store objects in them. There's a very famous database called MongoDB that uses JSON to store representations of database. And so instead of using SQL, you just say, here's my JavaScript, store it please, and it shoves it in there. What happens if we do, we got, what is our user? So user is an object. We can do like a JSON.encode user, right? JSON. What is our stupid thing? JSON.stringify. Yep. User. Yeah. So we can take that entire representation of an object that we created and has all those cool functions and stuff, and strip out all those properties. So that was, to me, we were talking a little bit earlier of like, why would you put something in the prototype versus something in the other thing? Is that like the values are the things that you want to save and store and care about, right? So we can pass that straight to JSON stringify and get. So let's log in right now, right? Like me. Let's say password. Log in. I can run JSON stringify, and now that's my user object, and I can store this anywhere I want. And maybe we have a method that says like on constructor, we say if what do we call it? Session or local storage dot get item user, right? We say var JSON equals JSON dot parse local storage dot get item user, right? So in our constructor, when we load this page every time, if we've got a here, let's show this off real quick as a real world example. I say this dot email equals JSON or JSON dot email. I can say this dot ID equals JSON dot ID. This dot first equals JSON dot first. This dot last equals JSON dot last. Right? So I've said if this exists in local storage, parse it out and then assign it so that when I call new whatever and the page loads, my object is set up and ready to go. So we probably have to have a right. So we do login. That's where we're doing this in the first place. We probably want to go local storage dot set item user, and we say JSON dot stringify this, right? So user is guest right now. If I log in, me at erichharrison.info, password, Okay, great. So now my user object has all my information here, right? Now if I reload the page, if I type user right now, I'm logged in. Pretty cool, right? And so now maybe because I'm logged in, you know, we might write something in here that says like, here, form ID equals login form. Now let's wrap it in a div. Div ID equals login div. Okay. When we're logged in, we'll say document.getElement by ID login div dot inner HTML equals hello again, and we can use our let's use our cool template strings we learned about today. We'll say hello again this dot name, right? Oh, this dot first. Dang it. So now instead of a login box at all, I get this. What is this? Oh, this. I don't have this, so let's do if button. Okay, so what I'm doing here is this error is saying because we've just deleted that form, this is returning null, so I cannot add event listener on null, right? It's kind of what we were talking about, why we would want to write like a helper function for us, right? First of all, because document.getElement by ID is like a ton of letters. But secondly, we cannot attach something to null. So now that I've added this in here, right? Now I've got a beautiful page where I've logged myself in. Now our app can get interesting, and I can start saving scores, or in Leah's, like, track all my poker games, right? Leah, in your poker or in your blackjack app that you were building earlier, I noticed it was saving scores and stuff. Are you saving that to local storage so that I can track my progress over time?
No, I just now thought of that, and I that's what I've been thinking of
Cool.
to do that.
Because then I think like maybe the next evolution of that is that like you're going to track your stats for the session, and then you're going to stack each individual session, and then you can see like, I won more yesterday than I did today. Maybe you build a chart out of it as well.
Yeah, eventually, like when I add more games, I want to have like a profile, a personal profile with like stats for all your games. That'd be really cool.
That's perfect. And I think what I would encourage you to do, Leah, and I would encourage you to do the same thing, Andrew, and to some extent Estrella, as you're working on your respective apps, is that like you should start prototyping what your database will be in local storage before you actually have to store it in a real database and we put it on a server somewhere, because this is a perfect time to like, let's test it, let's make it work, and then once we learn databases, it'll be really easy for you to just be like, oh, okay, well, where I have local storage dot whatever, I'm going to change that to update tables, set value equals whatever. So you'll just literally be replacing like 2 or 3 lines of code. And if you're writing things like this, where you've got functions like save scores, all you have to do is just go to this function and be like, okay, I was saving my scores here. Now I'm going to save them in a different way. So you might, and maybe you want to keep both, right? The reason local storage is so powerful is it's client side. So maybe you're storing things local, and then every once in a while, maybe it's on a timeout or you've got a set interval that says like every 10 seconds or so, just save whatever I've got to the server. Something like that. Everyone following along? Cool. All right, we're going to stop there.